Friends, very good morning. Today we are going to discuss about the limit test for chlorides. This is a test which is used to know the amount of chlorides present in the given sample. Is it within the limits or not? How it is being done? What's the principle behind it? Here, if any compound consists of chlorides ions as an impurity, then how to detect it whether it is within the limits or not? This test is based upon the reaction of chloride ions present in the sample with silver nitrate. The silver nitrate reacts with the chloride ions in the presence of dilute nitric acid. When this silver nitrate reacts with chloride ions, it produces an opalescence. How this opalescence is produced? Let us look into it. Here, when the silver nitrate reacts with chloride ions in dilute nitric acid, it produces opalescence. And that opalescence produced is compared with the standard solution. If the opalescence produced by the sample solution is less than that of the standard solution, then it passes the limit test. How the reaction occurs? Let us look into it. So the chlorides are present in the form of sodium chloride, suppose, or it can be proposed in the form of ammonium chloride and others. Sodium chloride has sodium ions and chloride ions. It can react with silver nitrate. Silver has Ag plus silver ions or NO3 minus ions. These are anions, these are cations. Sodium chloride reacts with silver nitrate in the presence of dilute nitric acid. The chloride ions are electron rich. The silver ions are electron deficient. As we know, the electron rich species get attracted towards electron deficient species. This excess ions which is there with chlorine is transferred to the silver ions which is electron deficient, and an ionic bond is formed between silver ions and chloride ions. It gives rise to silver chloride. Nitrate ions NO3 minus, which is electron rich, combines with sodium plus, which is cations, and form sodium nitrate as the byproduct. This occurs in the presence of dilute nitric acid. It gives rise to silver chloride. Silver chloride is in the form of white precipitate. At it is in less amount, it forms a white opalescence. And sodium nitrate is the byproduct form. Silver chloride, which is formed, is insoluble in water. That's why it produces opalescence. Sodium nitrate, the salt which is formed, is soluble in water. It goes into water. This silver chloride, which is formed, gives opalescence to the reaction mixture. If this silver chloride amount of silver chloride formed depends upon the amount of chloride present in the sample. That's why this silver chloride concentration, if it is more, then chloride concentration is also higher. If it is less, it is also chloride ions is also less. This is how we compare the opalescence produced in the sample solution with that of the standard solution. Standard solution is one in which there is standard amount of chlorides already present in it. This standard solution has the chlorides, and when this sample solution has less opalescence means it has lesser chloride ions than the standard. That is, it is within the limit. Why this nitric acid is added? Here, nitric acid which we add in this limit test of chlorides gives acidity to the solution. In other words, it makes the reaction mixture acidic. When it is acidic, then silver chloride precipitates and the sodium nitrate, it enhances the solubility. That's why use dilute nitric acid to increase the acidity of the reaction mixture so that all the silver chloride which is present gets precipitated and sodium nitrate which is formed as the byproduct get dissolved in the water solution. It dissolves other impurities and it only precipitates silver chloride. It increases the specificity of the reaction. Sodium chloride, like sodium chloride, it can contain sodium bromide also. Then silver nitrate reacts with sodium bromide and I'll get silver bromide. And that also can get precipitate. That should not occur. That's why it we use this nitric acid so that it precipitates silver chlorides only. What is the procedure followed? We take two Nessler cylinder, one Nessler cylinder, we add the test sample, another Nessler cylinders, we add the standard sample. We take the specified amount of the sample as prescribed by Indian Pharmacopoeia and dissolve in around 20 ml of water taken in the Nessler cylinder. In another Nessler cylinder, we add 1 ml of standard chloride solution which has 25 parts per million chloride ions. Then, to both Nessler cylinder in which the test sample and standard sample is taken, we add 10 ml of dilute nitric acid to both of it. Then both the Nessler cylinder in which test sample and standard sample are present, we dilute to 50 ml mark of the Nessler cylinder. We have taken the sample, we added the dilute nitric acid and made up the volume to 50 ml. In test sample and in standard sample we have taken 1 ml of standard chloride solution. To both the test and the standard samples, we add 1 ml of zero point 0.1 molar silver nitrate solution. The silver nitrate reacts with the chloride ions present in the sample, gives rise to silver chloride. And this reaction gives opalescence. And we have to keep the reaction mixture for 5 minutes aside. When we keep for 5 minutes, the silver nitrate completely reacts with the sample, and this reaction gives rise to silver chloride, and this in turn gives rise to opalescence or turbidity. As we know, the turbidity or the opalescence produced is the function of the amount of chlorides present in the sample. Higher the chloride ions, higher the turbidity, lesser the chloride ions, lesser the turbidity. In standard solution, we have 25 parts per million chloride ions. It gives a standard opalescence. If our sample opalescence is lesser than that of the opalescence produced by the standard solution, then it indicates that chloride ions is within the limit, that is 25 parts per million. Now, if I show the figure, this will be the test solution and this will be the standard solution. You can see here the operations produced in the test solution is less than that of the standard solution. Means it has passed the test. Means in the given sample, chloride ions present is less than 25 parts per million. That is the standard. Now we have to look into how these reagents are prepared. We have used various reagents. We have used zero point 0.1 molar silver nitrate solution. How to prepare zero point 0.1 molar silver nitrate solution? We calculate the molecular weight. Silver nitrate molecular weight is 170 grams. What is molar solution? Number of moles of substance in 1000 ml of water. If 1 mole of substance is present in 1000 ml of water, it is 1 molar silver nitrate solution. 1 mole means molecular weight. If 1 mole means 170 grams. 170 grams, if I dilute to 1000 ml with water, it gives rise to 1 molar solution. If I want zero point 0.1 molar, I have to divide by 10. That's why if we dissolve 17 grams of silver nitrate in water and make up the volume to 1000 ml, we get 0 0.1 molar silver nitrate solution. Here, the silver nitrate solution should be stored in a light resistant container, that is amber colored bottle. Otherwise, the silver nitrate gets degraded. We can prepare chloride standard solution which contains 25 parts per million of chloride ions. We take 5 volumes of 0.0824% weight by volume solution of sodium chloride and make up the volume to 100 ml with water. What is 0.824% weight by volume solution? That is 82.4 milligrams of sodium chloride if I take and make up the volume to dissolve in 100 ml, then it gives 0.0824% solution. I take 5 volumes of this and make up the volume to 100 ml. Right? Sodium chloride, if I take, the molecular weight of sodium chloride is 40. Right? Zero point 0.4 grams, that is 400 mg, if I take, I get zero point 0.1 molar sodium chloride solution. I take one fifth of the zero point 0.1 molar solution, or I dilute zero point 0.1 molar solution by 5 times, I'll get 0.0824%. I take this 0.0824%, 5 volumes, and make up to 100 volumes with water. I'll get the standard chloride solution, which is containing 25 parts per million. Or how to prepare dilute nitric acid. Dilute nitric acid is 10% weight by weight of nitric acid. But nitric acid is in liquid form. When we had to take liquid form, we calculate the weight per volume or density. The density of nitric acid is 1.06. If I take 106 ml, it gives 100 grams. That's why instead of taking 100 grams, I take 106 ml of nitric acid and dilute to 1000 ml with water. I'll get 10% weight by weight of nitric acid. This limit test is used to know the amount of chloride impurities that may be present in water or food particles or pesticides or pharmaceutical. The water which we use may also contains chloride ions. When we use the tap water, definitely it gives the opalescence. That's why care should be taken that we should use deionized water for carrying out this test. If we use normal tap water, which also contains chloride ions, it precipitates that in the form of silver chloride, and the sample which we take, which has chloride impurities, also gets precipitated, and we get the wrong results. That's why we have to always use deionized water for carrying out the limit test for chlorides. This is all about the chloride limit test. In the next presentation, let us discuss with the limit test for other ions. Till then, have a nice day. Thank you.